Daniel MacArthur, and I'm going to show you how to make an obstacle detection system that uses sonar. This system consists of two devices, the distance sensor and the distance reporter, and these devices are connected together using an Ethernet cable. This is the distance sensor, and it uses an ultrasonic sensor purchased from Maxbotics. You can see inside there. And then this is the distance reporter that uses a red, yellow, and green LED here on the top to let you know how close you are to objects. So let's have a look at it in action.
The sensor can detect obstacles of different shapes and sizes, and the distances at which these LEDs light up can be adjusted in the code, which will be seen in a few minutes.
I specifically designed the sensor in two parts so that this part that goes underwater with the Seaperch would be a little bit less bulky and easier to waterproof. And then because this sensor is connected to the electrical box through this Ethernet cable, you don't have to worry about waterproofing this box. This part that goes under the water can just snap onto your Seaperch like this. And then this is just a typical wiring box you'd use for home wiring. And in this back corner I've popped out the perforated tabs. And this is where you can plug in your USB cable to your microcontroller, which is just sitting inside there. And this is just a jack that breaks out the wires from this cable and puts them where they need to go in the microcontroller. And then a few wires come out here from the microcontroller into the breadboard to turn on these LEDs.
Before we start building the sensor, let's quickly look at the physics that are involved. As I said before, this sensor works using sonar, which is achieved through the use of transducers, which convert electrical energy, like a voltage, to mechanical energy, in this case a sound wave, and vice versa. An electrical signal causes the transducer to vibrate at a certain frequency, and those vibrations make sound waves. The sensor first sends out a set of sound waves called a ping. When those sound waves reflect off of nearby objects, they come back to the transducer and cause it to vibrate. That vibration then creates an electrical signal which can be used to determine how long it took for the sound to travel to and from the object. We can then multiply that time by the speed of sound in water to find the distance to and from the object. The transducer that we are using for this sensor is the Maxbotics MB7062 ultrasonic sensor. Ultrasonic just means that the frequency of sound that it uses is higher than humans can hear. Since this sensor was intended to be used in air, it needs to be waterproofed so it can be used underwater with the Seaperch. Here's a list of the materials and tools you will need to build this sensor. First, I'll just show you how to wire the sensor itself. We only need to connect 3 of the pins shown on the left of this image: V+, ground, and the analog pin, which is the third pin from the top. V+ and ground are for the 5-volt power supply, and the analog pin is where we will be getting the distance reading.
I've already soldered up the wires onto this sensor, but I'll show you what you need to do to get yours wired up. So you'll take your Ethernet cable and you'll cut off one end like this. And then you'll strip back some of the blue insulation so you expose the 8 wires that are inside the cable. We'll only be using 3 of the wires, so you'll just cut back on each wire, you'll cut back about 1/4 inch of insulation. And then on the sensor, since this is covered up, here's just an example circuit board I have. You'll put the wire into this little hole on the sensor. Then you'll take your soldering iron and your solder, and make sure to use your safety glasses. And you'll put a little bit of solder on the tip of the soldering iron, like this. And you'll just put the tip of the soldering iron to that metal rim, and you'll heat it up, and as you bring in the solder, it'll melt around the wire and it'll fill in the hole. And then you can pull it away. And you'll do that for each of the 3 wires. So you'll need to make sure that you keep track of which colors you're using so that later on you'll know which wires to connect up to the microcontroller. Have the sensor all soldered up. You'll take your liquid electrical tape, which has an applicator that's like rubber cement, and you can just paint it on the back of the sensor and wait about 3 or 4 minutes, and then you can apply another coat on each side and just keep doing that until the entire sensor is covered like this. And what I did is I actually took a little bit of electrical tape and wrapped it around when I was finished to give it a little extra support. And I have this little extra set of wires here. This was for a different experiment, so yours won't be quite as bulky as this. Then you can take your PVC fittings. This is a female adapter with threads on the inside, and they can thread right onto the back of the sensor. And then just a short piece of PVC and an elbow. And you can drill out the back so that your wire can feed through. And then you'll slide these together. And then you just have another short piece of PVC pipe and a male adapter this time that screws into this snap-on T that can then hook onto your Seaperch.
Next, we'll wire up the electrical box. Here's a schematic of the whole setup. We've already wired the portion from the sensor to the RJ45 plug, so now we'll see how to wire the RJ45 jack and the Arduino board. Make sure to print out the schematic for reference while you're wiring.
Electrical box, where we will take the wires from our Ethernet cable and break them out into the Arduino microcontroller. So this is an RJ45 jack, and it has some pins here on the bottom. And when you connect your Ethernet cable in this jack, it breaks out those pins into certain ports out here where you can plug in wires. And I'll show you real quick how you can figure out where each of these pins go in the back. The jack, you'll just touch one probe to each of the wires, and then the other probe will check each of these until it changes like it did there. So you know that this port right here corresponds to that end pin on the jack. Once you know which 3 ports you need, you'll just take a short piece of wire like this, stripped on both ends, put one end of the wire into the port that you want to use, and most of the jacks come with a tool like this. If it didn't come with one, you can use just a screwdriver, flathead, and then you just push the wire into the port until it clicks in place. Then you take the other end, and as you see here, you'll plug it into the Arduino microcontroller in the pins that are shown in the schematic. So on this side here, you have your digital pins. In this bottom corner over here, you have your analog pins, and then your power comes in right here. The last thing we'll do for the wiring is to take the wires for the LEDs from pins 9, 10, and 11 on this board, and I'll just show you how to do that real quick. This is pin 11, this is for the green light, and I have this blue wire that's been stripped on both ends, and plug it into the Arduino controller over here, and then bring it into the breadboard. Now the breadboard has all these pins, and in each vertical row, like this, the pins are connected inside. So when I plug this wire into this pin, it will be connected to this resistor, this 270 ohm resistor. So we plug that in the same line, and then on the other end we'll take our green LED. It has a long leg and a short leg. The long leg is the positive end, and so we'll plug that in on the other side of this resistor, and then the negative side will go into the ground block, which I have on the very left side here with this yellow wire. So I'll plug it in like this. And you can do the same thing with your other 2 wires for your other LEDs. All wired up, you can use this USB cable to upload the program that I've included onto the Arduino. And then to check that you built this thing properly, you can take your sensor and move it at certain distances away from obstacles to make sure that the lights are changing colors appropriately.